Section 12.3, surface area of pyramids and cones. We're going to start once again with vocabulary, and it says that a vertex of a pyramid is the common vertex of the lateral faces of a pyramid. So if we come over here and look at our pentagonal pyramid, we can see that all the lateral faces meet right up here at the point, and this point where all lateral faces connect is called the vertex. So the vertex of the pyramid is where all of the lateral faces come together and connect to make that top point. And it says that the slant height of a regular pyramid is the height of a face of the regular pyramid. So what they're talking about here is the slant height would be from the vertex at the top, and it would go down this side to create a right angle with the base. If this is hard to visualize, go ahead and make a net of a pyramid. So if you can imagine all of these come up and create it would look like a star almost in your net, and the slant height is going to be the same. So if you're having trouble visualizing what the slant height would be, what it's going to look like, go ahead and construct a three-dimensional pyramid. So draw the net and then construct the 3D pyramid, and you should be able to visualize the slant height a little bit better. And it's important to make the distinction. The slant height, it goes along the faces. The regular height, so the actual height, would come down here to the base. So it would be straight from the top of the vertex all the way down to the base, and it would go to this point, so it would go to the center. That is the height of the pyramid, but the slant height goes along the faces. Alright, example 1. Find the area of a lateral face of a pyramid. It says that a regular square pyramid has a height of 15 centimeters and a base edge length of 16 centimeters. Find the area of each lateral face of the pyramid. Okay, so when we look at this, we're given the height. So we're given our height. It's right here. It's 15. We are given the base, so the entire base length. So it goes from here all the way to here. That's the entire base length. And we're trying to find the slant height. So what we did when we're trying to find the slant height, because we're going to need that to find the area of the lateral face, we've come down here and we've constructed a smaller triangle. So if you look, it's that blue triangle inside of here, so I'll outline it for you. This triangle here is the one that we're looking at down here. So we are half of the base, because the height, when it drops down, remember, we create it's an apothem. So we have an apothem which cuts the side length in half, and we've cut the side length in half. So we have two sides, and we're missing one side. So from here we can use Pythagorean theorem to find our slant height, which will be like a cursive L. So we have 15 squared plus 8 squared is equal to the slant height squared. And after you figure this out, the slant height will be 17. So the slant height is 17. And if we're finding the area of our lateral face, if you look, the lateral face is a triangle, so we're going to use the triangle formula. So the area formula for a triangle will be area is equal to 1/2, and we have base, and the only thing that's different here is the slant height. So we have area is equal to 1/2 the base times the slant height. And we are given all this information, so we have the area is equal to 1/2, and then the base of the entire lateral face, which is 16, and we'll multiply that by our slant height, which is 17. And after you multiply those all together, we will get 136 centimeters squared. We're finding an area, so remember, we have to square the units. Example 2 says to find the surface area of a pyramid. So we're going to find the surface area of the regular hexagonal pyramid. And the first thing we need to do, this is similar to when we were finding the surface area of the prisms. So we're going to start with finding the area of the base. The base is a regular hexagonal pyramid. So the base is regular, which means that all the side lengths are going to be congruent. So this goes back to 11.6 when we're dealing with finding the area of regular polygons. So we're going to use the same exact format here. So I want to find the area, so the area of my base, and I'm going to call that capital B. So the area of my base, and that is going to be equal to 1/2 multiplied by the apothem. And we could use perimeter, but instead I'm going to use the number of sides times the side length. So if we look at this, I have 1/2. Now the apothem, remember, is the line that goes from the center to the side of my polygon and creates a right angle. So that's given by 5 square root of 3. That's the apothem. It starts at the center, goes to the side, creates a right angle. So we have 5 square root of 3. The number of sides, for our number of sides, I suggest you guys do this as well. I like to count them up. Even though it's a hexagon, I know there's 6. I don't want to be incorrect and think something wrong, so I'm going to count them up. 1, 2, 3, 4, 5, 6, 6. And the side length, we have the entire side length, which is here, so that's 10. And we can use this. After we multiply this all together, we should get 259.808, and that's feet squared. So that's the area of the base. So we found the area of the base so far. So the next thing we need to do is find the area of the lateral faces. So LA, we're going to find our lateral area, and we'll set that equal to, well, we know it's 1/2, and my base here, so the entire base, the base length of my lateral face, that is also 10. So right here it's 10. And we have to multiply that by the slant height. So remember, the slant height goes from the vertex and it drops down to the side along the face. So it follows this face here, goes down. So that's going to be 14. And after you multiply that all together, we should get 70. But that's not all of our area, because we have we have 6 lateral faces. So we have 6 lateral faces, so we need to multiply 70 by 6. And that's going to give us 420 feet squared. And we're not done, because remember, we're looking for the surface area. So to find the surface area, I would add up the area of my base. I take the area of my base and I'd add it to the area of all my lateral faces. So I'm going to have 420 plus 259.808. And after I add those together, I should get 679.808. 679.808, and that, once again, since it's surface area, that's going to be feet squared. Make sure you look back in the problem. Don't just assume units squared or units. Always look back in the problem and see if you are given the units. Example 3, it says, what is the surface area of the right cone? The surface area formula. So the formula for this is going to be the surface area is equal to, and we're going to start with the circle, so that's pi r squared, and we're going to add pi r, which is once again the radius, and then the slant height. So that would be the what travels around, so like the lateral faces sort of the cone. So it goes around. So we have our answers here at the top that we're given are in terms of pi, so I'm going to keep them the same. And so let's plug in what I know. So I know pi. My radius is 6, because 6 squared. So we look up here at our circle, so the radius is here. So this is the radius. And we're going to add, well, I know pi. I know my radius. However, I do not know my slant height, which is located here. I do not know the slant height. So I can come down here and construct what this triangle would look like on the side. I have 2 of my legs, so I have 6 and 8. So to find my third side, so to find my slant height, I can use, once again, Pythagorean theorem. So I'm going to have 8 squared plus 6 squared is equal to the slant height squared. And when you add both those together, you're going to get 100 is equal to the slant height squared. Take the square root, and slant height is equal to 10. So now I have my slant height, so I can come back up here, plug it in my formula. And we're going to keep our answer in terms of pi because that's what the multiple choices are given in. So I'm going to have 36 pi plus 60 pi. And when I add those together, I will have 96 pi. And don't forget the units on this. We're going to use meters squared because it's surface area. Look up here, so our final answer should be letter B. Example 4. Find the lateral area of a cone. The traffic cone can be approximated by a right cone with radius 5.7 inches and height 18 inches. Find the approximate lateral area of the traffic cone. So for this one, we could use the traffic cone. However, I would suggest drawing an actual right cone. So I'm going to do that as well. So I'm going to come over here. We'll keep it similar. So I have my cone, my base. Cone goes up. And it says that the radius is 5.7. So I'm going to draw my radius, which goes from here to here. And I know that's 5.7 inches. And it says that I also know my height. So I know the actual height of my pyramid. So that goes from the vertex, drops through the cone to the center, creates a right angle, and we know the height of the cone is 18 inches. So 18 inches. And to find the lateral area, remember I need my slant height. So once again, I'm given a triangle, so I can use both of these. I'm given the legs, so to find my slant height, I would do 18 squared plus 5.7 squared is equal to my slant height squared. And once we solve the left-hand side, we should have the slant height is equal to 18.9. So now that I've got my slant height, I can find the lateral area of my cone. So the lateral area, now the formula for this, so the lateral area, if you remember, if we look back here, we have the lateral area. So we have the area of the circle is here, but we don't need that, right? What we need is the lateral area, and that's represented by pi times r times the slant height. So that is our lateral area. This here is our lateral area. So I can plug that formula in. So I have pi times the radius times the slant height. And from here, we just plug things into the formula. So we have pi. The radius, they said, was 5.7. And the slant height we found to be 18.9. And when we multiply that all out together, we should get 338.4. And check back, does it give us the units? It does indeed, so it's inches. And since it's surface area, it would be inches squared.